All right, we are live. Hello, everybody. I hope you can hear me. I hope you can see me. Good evening, good afternoon, good morning, depending where you are. So today's episode is focused on the AWS IoT Message Broker. I hope you know what a message broker is already, because we are talking a lot about the message brokers and messaging systems. My name is Wojtek and I'm AWS Maniac, and I would like to introduce you to another service from the AWS Messaging Services series. A quick recap what we are doing here. It's the 7th episode from the AWS Messaging Services series. We already covered SNS, SQS, Amazon MQ, which is the fully managed version of Apache ActiveMQ, Kinesis data streams, EventBridge, MSK, which is the managed Kafka. And today we will talk about the service dedicated for Internet of Things and for the MQTT protocol. Outside of today, we've got 3 episodes until we finish. So AWS AppSync, which is scheduled for the next week. In 2 weeks, we will talk about Pinpoint, and last but not least, we will talk about Amazon's Kinesis video streams, especially the signaling channels, which is related to WebRTC. If you have any questions on the chat, feel free to do it. You can find me on Twitter, you can find me on LinkedIn. I see that we've got, as always, Flashpoint. Hello. So without further ado, let's focus on the today's main theme. One more recap. It is a deep dive, so I hope that you will learn something today. I will try to highlight the proper use cases and differences between those services. And I hope you will learn something new today about this particular service. So AWS IoT Message Broker is basically a fully managed MQTT broker, which is a part of the AWS IoT Core suite. And we will talk about this difference between those two services, because if you would like to look for IoT Message Broker in particular, you will not find a separate service. AWS has the whole branch of services called, with an umbrella term, AWS IoT. The whole branch consists from such services like the messaging bus, which is something that we'll talk about today. There's also additional stuff like Greengrass, like the device shadows, all those elements that are managing the edge devices or IoT devices. Also, there are stuff related with security, with the analytics. So a lot of services under one umbrella term. And inside this, the whole branch of those services, there is one particular, which is the core of everything related to IoT. And that's called AWS IoT Core. Inside IoT Core, from the other hand, we've got batch jobs, we've got rules, and we also have message broker. So we will talk not fully about the IoT Core today, because it's a complicated beast in itself, but we will focus on the part of that service which is dedicated to MQTT and to messaging. As I said, it's a fully managed message broker. It's a publish subscribe service. It enables you to send and receive messages from the IoT Core and in general from IoT devices to AWS via IoT Core service, which is the core messaging bus. As I said, it's a part of the bigger suite, and it fully integrates with AWS ecosystem. I already mentioned that we've got rules, we've got jobs. Everything is interconnected with the AWS services and helps you with the with integration, with the ease of use, and triggering particular actions after certain events arrive to our bus. One side note here, in many cases, and many people actually raise a concern that using AWS IoT in general and IoT Core in particular will be a problematic because of the vendor lock-in. And I think that it's misguided, because if you will think and look how the IoT Core is built, it's fully based on the MQTT, and we will talk about this today. So architecturally wise, it should be easy to replace, and it will be easy to replace. Also, we will talk about the differences between the official MQTT protocol and the supported version on the AWS side. There are some nuances that you need to be aware of that. However, on the architectural point of view, if you will use IoT Message Broker or you will use any other MQTT based message broker, you should be fine, and it should be very easy to replace. However, operationally, this will be a much harder to replicate and to replace this service, because the unique selling point of the whole service is to scale automatically, to do that you don't have to provision infrastructure and you don't have to deal with the integrations on your own. So the whole unique selling point is all about operations, and you are buying in by choosing this service to actually offload operations to AWS. So here lies the problem with the vendor lock-in, because it's not so easy to replace after introducing this service. It's not easy to replace that, because you will need to have a significant investment on your side. So let's talk about the whole service in details. As usually, I split this in the three parts. First things first, we will talk about architecture, a high-level overview, all building blocks, what are the integrations, what are the use cases. Secondly, we will talk about the operational part, so high availability, scalability, pricing, and security. Last but not least, best practices. We will choose between various services. We will talk about how to differentiate and distinguish between them, and we will talk how our service integrates with AWS ecosystem. Message Broker is based on MQTT as a protocol, but as a whole, as a message broker, is not an open source technology. Fun side note is that historically, the IoT suite was introduced after acquiring the company called Telemetry by Amazon in 2015. So it is one of the examples how Amazon builds their portfolio. They are actually buying in the companies and adding those services as a part of the AWS portfolio. The same thing happened with the Elemental, which is the company behind VOD, video streaming, and all of those video related use cases. And they are actually the part of the current suite on AWS portfolio, which is related to VOD, to streaming, and so on. All those services are called with an umbrella term AWS Elemental Video. So that's the strategy on the Amazon side to actually broaden out portfolio when it comes to the services available on the platform. Okay, let's talk about the architecture. So as usually, I chose to use the high-level picture from the website when you have a very simplistic and very crude point of view how IoT Core intermediates between the device that consumes and device and services that consumes those messages and device that publish and subscribe to those services. So first things first, if you would like to talk about MQTT, which we will do in a moment, you need to know that the whole point of this protocol is to connect the publishers and subscribers, because it's oriented around session, around topics, around publish and subscribe pattern. So if you would like to have ability to publish events from your device and have other devices or other services that are subscribing of those events and do some actions based on those events, that would be an interesting protocol to have. One more thing regarding MQTT is that it's very lightweight in its nature. And we will talk about the origin and the motivation behind this protocol, but more or less it's one of the lightest protocols, messaging protocols available in the market. Okay, so if we will talk about the much more detailed high-level overview, as I said, the IoT is a suite of services. So it consists from the rules engine, from device shadows management, from device registry, device gateway itself, which the message broker is a part. It provides authentication authorization layer, integration with the applications with third parties, and also you can have a device SDK that allows you to seamlessly integrate with the AWS ecosystem. So the IoT Core itself as a service, when we'll talk about device gateway, about message broker, it's not a huge vendor lock-in. However, using everything around IoT Core, like device SDKs and integrations, rules engines, device shadows, and so on, here lies the problem of the vendor lock-in, because you are buying into more things and more, and after having a significant amount of those services inside your architecture, it will be very hard to go out and actually change the underlying service. So bear in mind that IoT Core in itself, it should be really easy to replace. It should be a migration issue at least, not the whole problem with the vendor lock-in. So speaking about the MQTT and the main protocol behind the AWS IoT Message Broker, MQTT is an acronym which stands for Message Queuing Telemetry Transport. As I said, it's the open standard, which is very lightweight, focused on the publish, subscribe, and to transport messages between devices. It was originally developed by IBM in 1999 to monitor the oil pipeline throughout the desert. So you can imagine that in such environment, you've got very scarce resources related to networking, like limited throughput, limited bandwidth, and so on and so on. That's why they needed to create a very lightweight protocol from the scratch in order to support those requirements about connectivity, about intermediate connectivity, limited bandwidth, limited access to the internet. The protocol usually runs over TCP/IP, but there is no strict requirement regarding this particular layer. The only requirement is that network needs to provide an ordered and lossless bidirectional connections. And you can actually, on top of that, you can actually build any, this MQTT can be done on any protocols that supports those constraints. Additionally, when it comes to the MQTT itself, that it's supported in many message brokers, including AWS IoT Message Broker, is that you can publish messages with the MQTT itself, with WebSockets, but also classic HTTP 1.0 and HTTP 1.1. All aforementioned protocols are supported via both IP4 and IPv6. So there's no distinction between what is supported for the version 6 and version 4. We already several times defined what a broker is, but in this particular context, the most important message about what is the broker is that in this case, broker is an intermediary that stores information about topics and stores information about subscriptions, about sessions for the clients. And this is important when it comes to the classic environment and classic services, not the IoT itself, because if you would like to support like thousands and millions possibly of devices, you need to think upfront about capacity planning and provisioning of those brokers properly. Probably you need a clustered network of those brokers, some kind of replication mechanism, and so on and so on. For sure, the failure recovery, and so on and so on. Here, you don't have to be bothered by that. Everything is handled behind the scenes by AWS. So as the fully managed service actually provides those kind of capabilities. The most important thing regarding the broker itself is that we are exposing particular topics and clients are publishing on those topics, and then clients can receive messages by subscribing to those topics. And those subscriptions are stateful connections because, as I said, MQTT by default runs over the TCP IP. If you are sending messages to a topic via HTTP and HTTP 1 and 1.1, you're probably talking about publishing messages, not subscribing. There's no long polling and long polling connections support for MQTT, at least not on the IoT Message Broker side. So all of those subscriptions are supported by the stateful connections via TCP/IP. What is the topic then? As I said, it's a way of routing the messages from the clients and informing which clients receives what messages. A topic itself resembles the path-like structure because you are using the backslashes as a separations for the hierarchy. So you can imagine that you've got the main root of the whole topic hierarchy, and then you've got device type, location, and then the device ID, for example. And that actually resembles the particular device that sends messages from the particular type to those topics. So you can use any UTF compliant character inside the topic name. It is also case sensitive. Any character outside of backslash because it's required as a hierarchy separator. Additionally, each broker provides system topics that are revealing internal statistics and information about the message broker itself. For the AWS IoT Message Broker, they are prefixed by the $ AWS from the small caps. So yeah, if you would like to have information about the running connections, how many devices are currently connected, you can have those informations from the system topics, but also, of course, the CloudWatch metrics. We will talk about that in a moment. But bear in mind that if you will start the topic names from the $, you are entering the dangerous territory because the AWS $AWS is a reserved prefix for system topics from the service itself. What is the subscription then? As I said, it's basically a state when the client actually subscribes to a particular topic to receive messages over a stateful connection. And when we are defining a subscription, we can actually provide a wildcards, which are allowing you to fetch messages from multiple levels, not only one. You can use the plus, which is all about the one particular level. So you can have plus inside your hierarchy, at the end of the hierarchy, at the beginning, and so on and so on. But it will always match a single level. Then you've got the hash, which is about multiple levels, and you can have the catch-all subscription in this way. And if you would like to match from the beginning, you can use the $. It's totally different $, from the topic name for the system topics. So if you would like to subscribe to all the topics, system topics from the AWS IoT Message Broker, you need to use $$ AWS. Those two characters are totally different. And speaking about the subscription, MQTT has built in a notion of quality of service. And basically it's an agreement between the sender of data and the receiver of those messages that we are guarantee certain delivery for specific messages. And there are three modes of those quality of service. 0, which means at most once, and basically that means we fire and forget. We don't care about those particular messages that it needs to be published and in that particular session. 1 means at least once, so there's a delivery guarantee, but we can receive multiple copies of those messages. And 2 means exactly once, which is strict delivery guarantee. And this sounds very promising, but I have to warn you, at this moment, AWS IoT Message Broker does not support version 2 for quality of service. And the reason for that is, by nature, AWS IoT Message Broker is replicated and spread around multiple availability zones. And having exactly once strict delivery guarantee will be impossible to serve with the high availability scenarios that are currently handled by AWS. So that's the reason why they don't provide this at this moment. I also use a notion of a session. And as I said, MQTT has a persistent connections, and those sessions are more or less related to connections. So sessions are used to create a stable connectivity between client that has some kind of constraints and worse connectivity capabilities that, for example, can very easily reconnect. And persistent sessions are designed to overcome such problems. So those sessions are actually identifiers that we can leverage to reuse and store messages on the broker side that are not delivered in that particular session. And when the client reconnects, we will basically catch up with all those messages queued on the message broker side. So as you probably and very rightfully think, we do have some kind of acknowledgements, especially in the quality of service 1 and 2. So clients needs to acknowledge those messages properly in order to have this persistent session mechanism working correctly. So that's another notion that we need to introduce in order to support all those elements inside the MQTT protocol. And from the very high level, it looks basically like this. I probably know that for most of you, it's very easy to understand. But as I said, we've got two types of clients, those who are publishing events and those who are subscribing on the topics and then receives those messages via the stateful subscription. And MQTT broker is basically a stateful service that both accepts those messages, stores information about the subscriptions, about the sessions, and also forwards to those and routes those messages from publishers to subscribers. I also talked about the MQTT limitations when it comes to the support on the IoT Message Broker side. So at this moment, IoT Message Broker implementation is based on the version 3.1.1. But there are some differences from the specification. As I said, AWS IoT Message Broker does not support quality of service level 2. So there is unfortunately no way to have exactly once guarantee delivery guarantees on the IoT Message Broker at the moment. Additionally, AWS IoT Core does not support retained messages. What are the retained messages? So you can imagine a situation that, for example, a client connects to a subscription and there's no upcoming message for a very long period of time. And On the client side, he may either don't know if he connected properly, or maybe expect some kind of messages that be delivered periodically, or at least at when the connection was established properly. And in order to do not have any additional notion of, I don't know, health checks and stuff like that on the message level, there is a feature inside MQTT protocol, which is called retain message, which tells the broker to flag this particular message for those kind of subscriptions. And then when a new subscription will arrive, we would like to send this particular message as immediately after the new subscription is established. So it's like the last known default value that is waiting on the broker for new subscriptions to arrive. And based on that information and based on that message, client can react properly and obviously work fine and acknowledge that everything is there and connection was established properly. Unfortunately, at the moment, there is no way to have this feature on IoT Core. One additional thing related with the MQTT differences between the message broker and the specification is that on the IoT Message Broker side, two clients with the same client ID cannot connect concurrently to a message broker. And there is no such constraint on the regular MQTT protocol, but most of the message brokers are trying to enforce such constraint anyway, because it's related with the replication and scalability. So if you would like to avoid duplicated messages, duplicated subscriptions, you need to have some kind of way to block the similar client IDs, exactly the same client IDs to be precise, connecting to a single message broker. And last but not least, IoT Message Broker at the moment does not guarantee the orders in which messages and acknowledgements are received. And that sounds like a problem, but the truth is that it's not a problem from the application and consumer perspective, because we do not see those acknowledgements anyway. Where it can be a problem is on the publisher side, if we will have a quality of service level 2, because those acknowledgements and exactly once deliveries and so on are very tricky to handle on the publisher side properly. And MQTT as a protocol handles that, but it requires to have the guaranteed order of the messages and acknowledgements. So lack of support for quality of service level 2 is related with the replication and multiple availability zones and fully managed service on the AWS side, and also with this constraint that we do not guarantee the order. And there's additional stuff that everything is listed in the documentation, so you can find this inside the official AWS IoT Message Broker documentation. There are a few additional limitations that I did not put on the slide because those are either niche or less severe in consequences when it comes to those which are listed here. So speaking about other stuff, let's talk about the use cases and how to handle where the IoT Message Broker can be handled and can be used properly. First things first, as name suggests, Internet of Things for sure. All kind of connected devices. All those elements are pretty good examples of the services and the use cases that we can use the service. Additionally, if you have any kind of constrained connectivity and you need publish subscribe mechanism, MQTT will be a good candidate to handle this properly. So if you would like to have reliable messaging in an environment of constrained connectivity, I can strongly suggest MQTT and leveraging for example, AWS IoT Message Broker. You may remember from a third episode when we talked about Amazon MQ that Apache ActiveMQ also supports MQTT, and that's true. We will talk about what are the differences between those two services and when to use which. Additional examples regarding those mentioned domains: embedded devices, telemetry, all kind of telemetry, publish, subscribe, and slow connections, limited bandwidth, low energy devices, using, for example, satellite connectivity. All those elements are pretty good candidates to use MQTT and probably AWS IoT Message Broker as well. What kind of companies are using this service? For example, Volkswagen, which uses the whole IoT suite, including the IoT analytics, IoT site-wise, and incorporates AWS IoT into the Industry 4.0 trend. Additionally, LG Electronics, iRobot, those two are actually pretty good and very good explanations why consumer electronics that needs to be connected to cloud, what kind of elements can leverage from those kind of services that are fully managed and providing the ability to manage the Internet of Things. Additionally, Bayer, Woodside, all those services and all those companies are actually providing the also both consumer electronics and also Industry 4.0, which requires a lot of communication with the sensors, with the multiple devices, and so on. And that concludes the part one. So we finished the architecture part, and I would like to move to the operational part. If there are any questions, feel free to ask on the chat. Okay, so we can move to the operation part. And speaking about operations, I think that the high availability is the main thing that actually that is provided by those fully managed services, and is also a unique selling point, which is very important for the ability to have a reliable service. From the start, AWS IoT Message Broker uses multi-AZ replication for the high availability, and that's the common standard for all fully managed services on AWS. If you need to have regional disaster recovery, you need to take care on your own for that part. So that's a very important message. All resources are region specific, and if you would like to have multi-region capabilities, you need to handle those on your own. Second important point about the operational part is scalability, and as a fully managed service, IoT Message Broker handles scaling in and scaling out automatically. And it does that by the current traffic, needed throughput, amount of subscription, amount of stateful connections. There is no need for capacity planning nor provisioning, and that's a huge sales point. Especially important for people that know a bit and had to manage the significant MQTT message brokers, clusters, and so on. Okay, but how much does it cost then? Well, first things first, there is a free tier. I know that in most cases it's unsuitable, but it's a great thing for testing and checking and playing with the service itself. But the whole pricing model is done in the pay-as-you-go manner. So more or less you are paying per active connections, per messages that are sent, and connections you are paying per minutes, per million minutes to be precise, messages per billion messages that are sent, device shadows and device registry. You are paying per million operations done on those elements, and you are paying for the rules engine. So per million rules that are triggered or actions that are executed as a thing. And a very important thing regarding the rules engine is that all those actions that are triggered and executed are counting in to 1 million rules that are packaged for the payments. So if you have rules that are both triggered and they are executing some kind of actions, you may pay for two things here. So keep that in mind. Very important aspect regarding all kind of IoT is how to provide security. And AWS IoT as a whole suite provides information and provides additional services to support the security layer. But at this very low level, when it comes to the security in transit and security at rest, you've got a plethora of options that you can use. So speaking about authentication and authorization, it fully integrates with the IAM. So you can leverage the IAM roles and IAM policies. The same goes with security credentials. You can create a very precise IoT policies for the devices. You can generate IoT certificates. The same goes with the certificate manager, with the private CAs, and so on and so on. You can have additionally AWS user management with the IAM, and you can have the Amazon Cognito identity as a provider, which allows you to have the authentication provider token and also role policies, IoT policies for the devices. So the full integration with the security suite is in place. Additionally, when it comes to connectivity and encryption in transit, all services are using SSL and TLS. And even if your devices are constrained when it comes to the hardware specifications, there is a huge amount of ciphers available and supported, and you can actually have many of those, not so many of those implemented on your side, but they will be accepted on the message broker side. So you don't have to be worried about this particular element. And when it comes to the triggering certain jobs and certain actions based on our rules, you can have a full integration with AWS IAM, and then you can invoke just those services that you need, as you will usually do with the very fine-grained permissions on the IAM. So that was a quick part about the operations, and let's now talk about the best practices and what kind of best practices we can employ here with this service. So let's start with the differences between particular services. And on the first side, let's talk about the difference between IoT Message Broker and SNS. This distinction between those two services should be very easy, even though that those two services are very similar in the sense that both are published subscribed services. So if you would like to have Internet of Things use case, and you would like to leverage the either full IoT suite, or you need to use features like rules and jobs, which we will talk about in a moment, I would recommend to use AWS IoT Message Broker as a thing. If you would like to, from the other hand, have publish subscribe to multiple different clients and types of clients, and you don't have to focus only on the IoT, then SNS will be a good choice. Difference between SQS and IoT Message Broker is even more simpler. IoT Message Broker as a thing does not provide queuing capabilities. So the distinction between those two services is really simple. If you need queues and if you need to have the decoupling mechanism that allows you for the queuing with retention, SQS is the way to go, especially if you are building the service from the ground up, from zero, and you don't have an existing message broker. From the other hand, if you would like to have IoT connectivity, you need to have publish subscribe, or you would like to integrate with the rules, jobs, IoT suite, etc., then feel free to use AWS IoT Message Broker. Here is probably the most problematic service to compare with: Amazon MQ versus IoT Message Broker. Both are supporting MQTT. And what is the difference between those two? So once again, if you need just MQTT protocol, but there's no need for Internet of Things capabilities, or you need quality of service level 2, or you need additional things, but you don't want to focus on the IoT use case solely, Amazon MQ will be more flexible solution. It's even more simpler if you have an existing message broker already, because in that sense, you probably will be much safer on the Amazon MQ. From the other hand, if you would like to leverage stuff like rules and jobs from the IoT suite, then Message Broker is the way to go. So both the common element from those two sets, IoT and also AWS integrations, that is the pattern for using IoT Message Broker as a service. Difference between Message Broker and KDS, so Kinesis Data Streams, it is simpler. If you need durable event log and buffering capabilities, then use the Kinesis Data Streams. If your consumers can deal with the shared throughput and filtering, it's not needed. Again, Kinesis Data Streams. If you need IoT use cases, use IoT Message Broker. Difference between Event Bridge and Message Broker, again, simple thing. Event Bridge is used for message routing and filtering capabilities and consumer fan-out. You probably have a different set of requirements if you are concerned by the IoT Message Broker anyway. And difference between Message Broker and Managed Kafka. Well, this might sound a little bit tricky, but it's not. In most cases, if you need MQTT, it rules out Kafka. If you would like to have the ability to have a durable log of events and you don't need MQTT, well, MSK and KDS is the thing to choose from. So the only problematic choice is between IoT Message Broker and Amazon MQ. And in my opinion, if you have an existing message broker already for MQTT on premise, probably the safer choice will be to migrate to Amazon MQ and then maybe re-architect to AWS IoT Message Broker. From the other hand, if you know from the start that you don't need quality of service level 2, you want to integrate with AWS service, and you would like to leverage rules and jobs, yep, that's probably a use case for IoT Message Broker then. Rest of the services and comparison between those, it's fairly easy to do. Speaking about integrations, you've got two ways with integrating with AWS services. One way is to use rules. And rules is basically an ability to interact with AWS service. So you are creating those rules that describes if such event arrives to a particular topic, I would like to perform this action. And rules are analyzed based on the topic stream of events. So if any message arrives to MQTT topic, then actions will be performed based on the stream of events that comes to the topic. What kind of integrations you have? You can send push notifications to all users using Amazon SNS. You can publish data to Amazon SQSQ, and so on and so on. Those integrations are literally integrations like on the Lambda side, for example, that would be a good analogy. So you can actually have just an action that it's done after this trigger is actually this particular rule is evaluated due to the trigger that invoked this rule. So it is a way to interact with other services, other parts of services based on the messaging that comes from your devices. From the other hand, you've got jobs. And jobs is the way to execute and do some kind of set of remote operations that will be scheduled and sent to one or more device connected to AWS IoT. In order to use jobs, you need to have the integration with the device shadows, device registry, and so on and so on. But you can also have rules that are scheduling jobs on those devices. An example for a job can be, for example, installing, downloading the firmware updates, rebooting those devices, or so on and so on and so on. So those jobs are executed on the devices, on the edge, but they are scheduled and managed on the AWS and cloud side. So you can define those set of remote operations based on your needs and based on your integrations. What kind of integrations do we have if you would like to pick this visually? So here you get an example from AWS blog post when they have a ESP32 device which integrates with the IoT Core via MQTT. It sends the messages to the topic. Then on the IoT Core, you've got a rule that invokes Lambda, and that Lambda actually does some kind of job. And then if somebody else would like to send information back to the ESP32 device, then you can have the additional IoT topic that is used to send information to via IoT Core to the device back and forth. So it allows you for a bidirectional communication, but with use of two topics, obviously, because one topic is used from device to the cloud and one will be used from the cloud to device. If you would like to schedule jobs, you don't have to implement any additional topics and communication. In order to have those jobs to be executed on the devices, you need to have device shadows and the registration inside the IoT Core. But other than that, you don't need anything more. Another example is to how to integrate multiple MQTT brokers together. And you can have this ability to have federation when it comes to the MQTT. So you can have MQTT broker in your local environment that handles the traffic from multiple devices. And then via the IoT MQTT protocol, you can have a federation between IoT Core Message Broker and MQTT broker on premises. For example, connection between Mosquito and AWS IoT Core. This is actually a diagram from the blog post that explains how to connect Mosquito with the IoT Core together. And yeah, that's everything what I prepared for today. So I hope it was enjoyable. I hope that you will have some questions right now. And yeah, I will wait for them for a moment. In the meantime, I can remind you that in the next week, we've got the next episode about the AWS AppSync. In 2 weeks, we've got the Amazon Pinpoint. And last but not least, we will talk about Amazon Kinesis video streams signaling channels. Yeah, Flashpoint says that wish I had any IoT projects to do. That's actually a very fair point. I think that there are some great companies that are using AWS IoT as a suite in general, but I don't know if this thing is so popular outside of those companies. But if you would like to listen about the great use cases and great examples, I can strongly recommend you following a guy named Ben Kehoe on Twitter, which is head of engineering at iRobot. They are having tremendous amount of examples of serverless, of AWS IoT, how to integrate those two things together. And there are some great examples from Serverless Conf when they are showing how iRobot and Roomba in particular is leveraging AWS as a platform to have a reliable backend in the cloud. But IoT projects are in general very, they looks great, and they are very encouraging because they are touching both hardware and software and backend and so on. That's appealing to us engineers. I totally agree with you. So are there any other questions? I think they are not. So 3, 2, 1. And that's everything for today. Thank you very much for your attention. Thank you very much for the participation, and see you next week. Bye.